Given 2 hydrogens plus 1 oxygen going to 2 waters, create the multimole ratios between oxygen and water. The first thing that you're going to do is identify the 2 variables, the 2 molecules that you care about. They're given in the problem. So we have oxygen and we have water. You'll visually connect them in the problem, and then you will take the coefficients that were given in the equation. The coefficient in front of oxygen is invisible, which makes it 1. You'll insert the word mole, and then you'll give the formula of the molecule in question, so 1 mole of oxygen, and we will then look to water, and we will say for every 1 mole of water, we will have coefficient in front of the second molecule, 2 moles of water. So for every 1 mole of oxygen, we have 2 moles of water. We do need this ratio flipped just in case we need it in another way for another problem. So I'm going to go ahead and do that. So I see that currently moles of water is on the bottom, so that means that I will put it on the top for my flipped fraction. So I will say 2 moles water for every 1 mole of oxygen. How many moles of oxygen are required to make 4.65 moles of water? You'll notice that I have brackets around my number. This is because your number on your problem could possibly be different. So this number can be subbed out, but every other step that I am going to take is going to be exactly the same, no matter what number you have. I'm going to read the question. It's going to say how many moles. How many is the unit, or is the variable x? That's how we ask questions in math. Moles, unit attached to the question word. O2, compound attached to the unit. So how many moles of O2 become x mole O2 are required to make is a equals. Then we have the number given in the problem, which is that 4.65 moles water. Then I'll go ahead and set up my dimensional analysis train track. Now that I have this set up, I can go ahead and choose between the multiple ratios that I have already created to see which one will be the correct option. So currently I have moles of water on the top of my dimensional analysis train track. Remember that in order to cancel something, I need it in the numerator and in the denominator. Since I currently have moles of water in the numerator, I will need to pick the version of the conversion factor that has moles of water in the denominator. So that is the version that I will choose. Moles of water will cancel, as it is on the top and on the bottom. This will leave me with the only English left in my math being moles of oxygen, which was the unit that I said that I wanted. So that means I can go ahead and move forward with my problem. I will multiply everything that appears on the top, so 4.65 times 1, and I will divide by everything on the bottom, so that will be 2. I can then plug that into my calculator. That will give me the number 2.325. I want to only have 3 decimals whenever I plug my answer into Blend. This is already in 3 decimals, so that means I don't need to round or do anything else. And I'll just attach the only English left in my math, the unit that I said that I wanted, moles of oxygen, before I box in my final answer. How many moles of water are produced when 4.98 moles of oxygen react? My 4.98 is inside of brackets because my number may be different than yours, but all of the steps that I am going to take to solve this problem will be the exact same regardless of this number. How many moles of water will turn into X moles water? How many is the X moles of water, H2O, are produced when is my equal sign, and then I will plug in the number that was given in the problem, 4.98 moles of O2 will turn into mole O2. Then I will set up my dimensional analysis train track. I currently have moles of oxygen in the numerator. In order to cancel moles of oxygen, I need to choose the version of the conversion factor that has moles of oxygen in the denominator. That will be this blue version. So that is what I will plug in. Moles of oxygen appear at the top and at the bottom, so they will cancel out, leaving me with the only English left in my math being moles of H2O, which was the unit that I said that I wanted. That means that I can go ahead and start plugging that into the calculator. So I will have everything that is on top being multiplied together, and I will divide by everything that is on the bottom. So 4.98 times 2 divided by 1. That will give me the number 9.96. Blend once 3 decimal places. However, it will delete any extraneous zeros, so I'm just going to go ahead and leave that as my answer and write the only English left in my math, the unit that I said that I wanted, moles of water, before I box in my final answer. Given 1 lead 2 hydroxide and 2 hydrogen chlorides going to 2 waters and 1 lead 2 chloride. Create the multimole ratio between lead 2 hydroxide, PbOH2, and hydrogen chloride, HCl. I'm going to go ahead and I'm going to visually connect the only molecules that I care about. They are going to be stated in the problem as lead 2 hydroxide and hydrogen chloride. I will visually connect them in the balanced chemical equation. Then I'm going to look to see what the coefficient is in front of each. The coefficient in front of lead 2 hydroxide is invisible, so that means it's a 1. So I will say 1, then I will insert the word mole, and then I will write the compound formula, PbOH2. For every 1 PbOH2, there was coefficient in front, 2, insert the word mole, hydrogen chlorides. I may need the conversion factor in another format, so I'm going to go ahead and flip it. For every 2 moles of hydrogen chloride, there will be 1 mole of lead 2 hydroxide. How many moles of hydrogen chloride are required to react with 5.01 moles of lead 2 hydroxide? My number here is inside of brackets because my number may be different than yours. However, all of the steps that I will take to solve this problem will be the exact same regardless of this number. I'm going to go ahead and translate the English problem into math. How many moles will turn into X mole? Compound attached to that unit, hydrogen chloride, are required to react with is my equal sign, and the number given in the problem, 5.01 unit moles of lead 2 hydroxide, PbOH2. In a previous problem, we have already established the mole to mole ratios, so that is what I will be referencing when I go to choose. Currently, I have moles of lead 2 hydroxide in the numerator. In order for it to cancel, I need it in the denominator, so I will reference back to my previous problem, and I will choose the version of the conversion factor that has moles of lead 2 hydroxide in the bottom. That will be this blue one, so that is what I will plug in. Moles of lead 2 hydroxide appear in the numerator and in the denominator, which means that they will cancel. And that will leave me with the only English left in my math being moles of hydrogen chloride, which is the unit that I said that I wanted. So I can go ahead and write out my problem. So 5.01 times 2 divided by 1. Then I will plug that into the calculator. And that will give me the answer, 10.02. Blend once 3 decimals, but it will eliminate any extraneous zeros. So I will just move forward and attach the unit that was left in my math, moles of hydrogen chloride, which is again the same thing that I said that I wanted before boxing in my final answer. How many moles of lead 2 hydroxide are required to react with 3.93 moles of hydrogen chloride? I'm going to go ahead and start translating this problem from English to math. How many will turn into X moles, and then unit, the molecule that was attached to the unit, lead 2 hydroxide. Are required to react with is my equal sign. You'll notice that my number is within brackets. This is because my number may be different than yours. However, all of the steps that I will take in order to solve this problem will be the same, regardless of what your number is. So number given in the problem, 3.93 moles of hydrogen chloride. Then I'll go ahead and set up my train tracks. Now that I have my train track set up, I can go ahead and choose the mole to mole ratio that will allow me to cancel out moles of hydrogen chloride. I have already solved for the mole to mole ratio between lead 2 hydroxide and hydrogen chloride in a previous problem, so that is what I will be referencing. With moles of hydrogen chloride already being in the numerator, I need to choose the version of the conversion factor that has moles of hydrogen chloride in the denominator in order to allow me to cancel out the unit moles of hydrogen chloride. As I reference my multiple ratios that I solved for in a previous problem, I can see that the version of the conversion factor that has moles of hydrogen chloride in the denominator is this red version, so that is the one that I will be using and plugging into my problem. Now that moles of hydrogen chloride appear at the top and at the bottom of my fraction, I can go ahead and cancel those out, leaving me exclusively with the unit moles of lead 2 hydroxide, which was the unit that I said that I wanted, which means that I can go ahead and move forward with solving this problem. So that means I will go ahead and multiply everything that is in the numerator, so 3.93 times 1, and I will divide by everything in the denominator, which is in this case 2. 3.93 times 1 divided by 2 will give me the number 1.965. Blend once 3 decimal places. It already has 3 decimal places, which means that I'm going to go ahead and just plug in the unit that was left over. Moles of lead 2 hydroxide before boxing my final answer. Given 2 aluminums plus 3 hydrogen sulfates, going to 1 aluminum sulfate and 3 hydrogen molecules, create the multiple ratios between hydrogen sulfate and aluminum. I'm going to identify the only compounds that I care about. They will appear in the problem, and then I will also underline them in the equation. So I have hydrogen sulfate and I also have aluminum. I will visually connect them, and then I will reference the coefficients that are in front of the compounds when making my multiple ratios. The coefficient in front of aluminum is 2, so I will have 2, the word mole, and then aluminum is just Al. For every 2 moles of aluminum, I will have coefficient in front of the compound 3, inserting the word mole of hydrogen sulfide. This is not the only way that I could possibly need this multiple ratio, so I'm going to go ahead and I'm going to flip it so that I can have both available to me. So I have previously said for every 2 moles of aluminum, I will have 3 moles of hydrogen sulfide. This time I am saying for every 3 moles of hydrogen sulfide, I will have 2 moles of aluminum. How many moles of hydrogen sulfate are required to react with 7.75 moles of aluminum? You can see that my number is within brackets. That is because my number may be different than yours. However, all of the steps that I am going to take to solve this problem will be the exact same regardless of the number. I'm going to go ahead and I'm going to translate this English problem into math. How many will turn into X moles, compound attached to the unit, hydrogen sulfate, are required to react with is going to be my equal sign. And then the number given in the problem, 7.75 moles of aluminum. I'll go ahead and set up my train tracks. In a previous problem, I have identified the multiple ratios between hydrogen sulfate and aluminum, and that is what I will be using. Currently, I have moles of aluminum in the numerator. In order for that unit, moles of aluminum, to cancel, I need it to appear in the denominator. So as I reference my 2 versions of the conversion factor, I will choose the blue version as it is the one that has moles of aluminum in the denominator. Moles of aluminum appearing in the numerator and in the denominator will cancel. That will leave me with the unit moles of hydrogen sulfate, which is the thing that I said that I wanted, so that can mean that I can go ahead and solve the problem. I will multiply everything in the numerator, so 7.75 times 3, and I will divide by everything in the denominator, so I will be dividing by 2. 7.75 times 3 divided by 2 will give me the number 11.625. Blend once 3 decimal places, and it already has 3, so that means I can go ahead and attach the unit that I solved for, which was moles of hydrogen sulfate, before I box my final answer. How many moles of aluminum are required to react with 4.72 moles of hydrogen sulfate? As you can see, my number is within brackets. This is because your number may appear different. However, the steps that I will take to solve this problem will be the exact same as you would regardless of the number. I'm going to go ahead and I'm going to translate this problem from English to math. How many will translate to X moles of aluminum, mole AL, are required to react with is my equal sign, number given in the problem, 4.72. Moles of hydrogen sulfate will turn into mole H2SO4. I'll go ahead and set up my dimensional analysis train track. Now that I have this set up, I need the mole-to-mole ratio between aluminum and hydrogen sulfate. I have already solved for this in a previous problem, so that is what I will be referencing. Currently, I have moles of hydrogen sulfate in the numerator, which means that I need it in the denominator in order for it to cancel. The version of the conversion factor that allows me to do that will be this red version, where I have 2 moles of aluminum on the top and 3 moles of H2SO4 hydrogen sulfate on the bottom. So that is what I will be plugging in. Moles of hydrogen sulfate will appear at the top and at the bottom, which means that they can go ahead and cancel out, leaving me only with the unit moles of aluminum, which is the thing that I said that I wanted, so I can go ahead and plug that into the calculator. I will be multiplying everything that is in the numerator, so 4.72 times 2, and I will be divided by everything in the denominator, so I will be dividing by 3. 4.72 times 2 divided by 3 will give me the number 3.14666667. Blend once 3 decimal places, 1, 2, 3. So this 6 is the last number that I care about. I'll look over to see if I need to round up. 6 does make me round up, so that means that my final answer would be 3.147. Only English left in my math. Moles of aluminum would be my final boxed answer. Given 2 C2H2 dicarbon dihydride and 5 oxygens producing 4 carbon dioxides and 2 waters, create the mole-to-mole ratio between oxygen and carbon dioxide. I'm going to go ahead and identify the variables that I care about, or molecules that I care about. They will appear in the problem. I have oxygen and I have carbon dioxide. I will visually connect them in the actual balanced equation. Then I will reference the coefficients as I create the mole-to-mole ratio. The coefficient in front of oxygen is 5, so I will have 5. I will insert the word mole and then oxygen, O2. And for every 5 moles of oxygen, I have coefficient in front of carbon dioxide, 4 moles of carbon dioxide. This is not the only version that I could possibly need in a problem, so I'm going to go ahead and I'm going to flip the fraction. When I do so, I will have the reverse ratio of 4 moles of carbon dioxide for every 5 moles of oxygen. How many moles of O2 are required to produce 1.78 moles of carbon dioxide? I'm going to go ahead and translate this problem from English to math. How many moles of O2 will turn into X mole O2 are required to produce is my equal sign. You'll notice that my number is within brackets. This is because my number may be different than yours. However, the steps that I'm going to be taking to solve this problem will be the exact same as you will have to take to solve your problem, regardless of the number given in the problem, 1.78 moles carbon dioxide. Currently, I have moles of carbon dioxide in the numerator, so that means I am going to have to pick the mole-to-mole ratio, which I solved for in a previous problem. That will allow me to cancel out moles of carbon dioxide. Since I currently have it in the numerator, I will need to choose the version of the conversion factor that has moles of carbon dioxide in the denominator. That will be my red version. Moles of carbon dioxide will cancel, leaving me with moles of oxygen, which was the unit that I said that I wanted, which means I can go ahead and solve the problem. I will be multiplying everything that is in the numerator, so that is 1.78 times 5, and I will be dividing by everything that is in the denominator, so that will be the 4. 1.78 times 5 divided by 4 will give me the number 2.225. This number already has 3 decimals, which is the desired number of decimals stated on Blend, so that means I do not need to round, and I can go ahead and just attach the unit that was left of my math, moles of oxygen, before boxing in my final answer. How many moles of carbon dioxide are required to consume 8.35 moles of oxygen? You'll notice that my number is within brackets. This is because my number is going to be different than yours. However, the steps that I will take to solve this problem will be the exact same, regardless of the number that you have on your problem. I'll go ahead and translate this current problem into math. How many will turn into X. Moles of carbon dioxide will turn into mole CO2. Are required to consume will be my equals sign. 8.35 is my number given in the problem. Moles oxygen, mole O2. I'll go ahead and set up my dimensional analysis train track. Once I do so, I can see that moles of oxygen are currently in the numerator, and I will need to pick the version of the conversion factor that I already solved for, the mole-to-mole ratio that I already solved for in a previous problem that contains moles of O2 in the denominator. This will be this blue version, so that is what I will plug in here. Moles of oxygen will cancel, leaving me with the unit moles of carbon dioxide, which was the unit that I said that I wanted. So that means I can go ahead and plug everything into the calculator. I will be multiplying everything that is in the numerator, and I will be dividing everything that is in the denominator. So I will have 8.35 times 4, and I will be dividing by 5. That gives me the number 6.68. This number has less than the 2 decimal places that Blend asked for. However, Blend will remove any extraneous zeros, so this is the number that I'm going to report. The only English left of my math and the unit that I said that I wanted as moles of CO2, and that will be my final boxed answer.